Electricity is everywhere. It powers basically our entire world. It's this huge, invisible force, but it's not just running wild, right? It's controlled. So the question is, how do we actually tame all that power and get it to do exactly what we want, when we want? Yeah, that really is the big question. Think about it. You flip a switch, a room lights up. You plug in your phone, it starts charging. It all feels so simple, so effortless. But behind that simplicity, there's this absolutely brilliant system of control making it all happen.
And the secret, really, it all comes down to two special types of materials. You can kind of think of them as the gatekeepers of electricity. One's job is to throw the gate wide open, and the other's job is to slam it shut.
So let's dive in. It's time to meet these two gatekeepers. They're the fundamental building blocks that make, well, pretty much all of our modern tech possible. We're talking about conductors and insulators. Okay, so at the most basic level, it really just boils down to this. Conductors, they're the green light for electricity. They say go, 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 and let it flow. Insulators, on the other hand, are the red light. They stop it cold. They're perfect opposites. But just saying go and stop is kind of the simple version. That's just the start. If we want to see what's really going on, we need to dig a little deeper and look at their core definitions. All right, so here are the more, let's say, official definitions. A conductor is a material that allows electric current to flow easily through it. An insulator does the opposite. It resists the flow of that current. So you see, it really all comes down to that one key difference, allowing versus resisting. Okay, that makes sense. But it kind of leads to the next big question, right? It's one thing to say they're different, but why? What's actually happening deep down at a microscopic level we can't even see that makes them behave so differently? Well, the answer? The big scientific secret? It all has to do with a tiny little particle you've definitely heard of, the electron. Seriously, the way these electrons behave inside a material, that's the key to absolutely everything here. So let's look at conductors first. Inside a conductor, the atoms have what scientists call free electrons. The best way to picture it is like a really crowded dance floor where everyone is just mingling and can easily move around and switch partners. These electrons are totally free to just hop from one atom to the next, carrying that electrical charge with them, almost like a wave passing through the crowd. Now, what about an insulator? Well, it is the complete opposite. Instead of a free-for-all on the dance floor, imagine everyone has a designated seat and they are not allowed to move. The electrons are tightly bound. They're basically locked in place, held firmly by their atoms. They can't move, so they can't create a current. And just like that, the flow of electricity is stopped dead in its tracks. All right, that's enough of the microscopic theory for a minute. Let's get practical. Where do we actually see these materials in action, in the real world? Well, when you think conductors, think metals. That's where you'll find the best ones. Copper is pretty much the king of electrical wiring for a reason. It's super conductive and doesn't cost a fortune. Of course, gold and silver are even better, which is why you'll find them in really high-end electronics where every last bit of performance counts. And then on the flip side, we have our insulators. Just think about the rubber handle on a screwdriver or that plastic coating on every single wire you've ever seen. Those materials are chosen for one specific reason. They don't let electricity pass through them. They're there to keep us safe. This table really lays it all out side by side, and you can see a clear pattern emerging, right? Look at electron movement, free versus tightly bound. Electrical conductivity, high versus low. Even their uses are total opposites. One is used for the wiring, the other is used for coating the wiring. In every single way that matters for electricity, they are fundamentally different. Okay, so this brings us to what might be the single most important point of this whole thing. This isn't some kind of competition, like conductors versus insulators. The truth is, modern technology is completely 100% dependent on them working together. Yeah, that's right. The real genius, the magic of electrical engineering, isn't about finding the best conductor or the best insulator. It's all about the clever, strategic way we combine them. Honestly, for most applications, one is pretty much useless without the other. Just look at a simple power cord. It is the perfect example of this partnership. The copper wires on the inside, that's your conductor. Think of it as the multi-lane highway for electricity to travel down. And the plastic coating on the outside, That's your insulator. It's the guardrail keeping all that powerful electrical traffic safely contained on the highway. You absolutely need both the highway and the guardrail to have a safe and effective journey. So we've pretty much mastered these two extremes, right? We have materials that always let electricity flow and materials that never do. But what if a material could be both? What if there was something in between? Something you could switch on and off? A material that could act like a conductor one second and an insulator the next? Well,